Hello everybody, I will start today another live coding session. So in my today's video, I will solve this question. Find all anagrams in a given to string s and p, return an array of all the return an array of all the start indices of p's anagram s. You may return the answer in any order. Okay. So in this question, I will be given two strings, s and p, and I will return the list of indexes. The index should the start indices of P's anagrams. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly. So in case of ABC, anagrams are ACB, AC. Yeah. So I will check some constraints. So first thing I'm going to confirm is length of S and P. Should it be an empty string or not? I will check. S and P cannot be an empty string. Good. So both of them are not empty strings. And also, I'm wondering, S and P. So, what's the type of characters can be included as the characters? And same for P. Only English alphabet or maybe lowercase, uppercase, or other any kind of periods dash. I will check, and I can see lowercase English letters only. So which means that they're all the number of possible characters is constant. Okay, which means that if I create a hash map of whose key is the lowercase English letters, which means that every possible character in the S or P, it takes only the constant time, and also iterating them takes only the constant. Good. Okay. That being said, I will take a look at say this and maybe. So I'm given this S, and because P's ranks as 3, I will take a look at this. There's 3 characters. This is yes. This is the anagram of ABC. Here, no. Here, yes. Here, no. Yes. This way, then I should return 0 to 4. So I think I've already done the brute force approach. So I do the kind of sliding window. Length is P. It assumes that length of string S is S and P. So there are, each um window ranks is P, and there are, window can start from every index except for the last two, which means that there s minus p position. For each, I will check length p characters if there's a same or not. So how can I check it? Probably I can use maybe I can sort there. I think I can window position. Yeah, this ends up with SP log p. But obviously I can optimize this. So instead of sorting, I will have the hash map. So there, this number of this is the frequency map. And when I move this, I update it, and then I will confirm if this is equal to map A1 B1 C1 B0 others. So in this way, what happens is that when I move the window, I should just pop out this A count 1 from the hash map, then increment this B to 2, this becomes 0 and B2, yeah. And then, so far it takes a constant time. And I check this with P's frequency map. This also takes a constant time because there are only 26 P's, and that's it. So in this way, time complexity should be, firstly, I have to initiate the P's frequency map, which takes P, and after that, I do the writing window. So there S minus P, window can start. And for each, it takes only the constant time. So it takes S plus. Okay. And I think I can speed up a little bit if length of S is smaller than length of P. Immediately, I will return empty string, empty array. Because P's length is larger than S, which, yeah, I can't find any anagram of P. This way, what happens is that because now S is larger than P, so I can ignore P part, then take O of S. And for space complexity, there should be only 20 P's in the frequency hash map. And also for frequency map of frequency map of P of 20 of 26, which is of 1. Okay, That being said, I start my presentation. Let me quickly solve that. Okay. Hmm. Then first, so the first window is first window. I create HP window. Elements. No, file throw and index. So now I can say this window valid with I will check. We compare two frequency map, and if there's the same, you can say current wins anagram. In that case, I will append the current index to them, moves the index and in the term. Okay. Yeah, I think this is it. So firstly, I will check if p is longer than string s. I will empty string. Otherwise, I create the counter of p, the frequency map of p, and then I use the two writing window from start index 0. Oh, I forgot something. So after moving it, I have to append the new character and create the new. Let me quickly say low and high. Just freaking up here. So my point is, I start from this and I check it here. So here, this is a valid window. And I will check if this is anagram. If it is anagram. And then what I will do is increment this and increment. And when doing this, I have to update the. And but I have to take care this high out of the range. So yeah, I have to do. Or maybe what I can do is I will check the frequency here. Yeah. But what I mean, I will do first. And I this until it is I plus 1. I can move. I will move. Okay. So now I do the anagram check first in line 52 for the initial window. Then I can say I still can move. I move it first. Check. I think this is. So now I will this. Like this. So for each character, I will check if frequency 1 and frequency 2 has, and if it's true, or if it's not true, I immediately, but all of the counter, all of the count for every character as same, I return true. Okay, let me dry run my code. I will try to this number 1 states when s t is longer than. Case I expect an empty list to be, and actually this is true. In line 48, length of s is 4, so I return an empty path. And I will test one more case. Let me okay. This case first 3. Oh. I expect index 0 and 1 should be 2 should not be. So in line 48, rank source is 4, rank 2. I go to line 51. I create the counter p. Frank is a1 b1. So I start with low high 0 and 2 minus 1 is 1. So low begins with 0 and high begins with 1. And the frequency around 6 begins with S, whose ranks is prefix of 2 S, AB. The frequency map begins. So now I initiate the return list, and in line 64, I compare key frequency map and map, and I trust this helper method. I don't cover this for the time saving parts, but if something goes wrong, I will come back and check. But let's assume this works correctly. In that case, in line 64, this should be true. So now low should be appended, 0 should be appended. Now in line 67, because high plus 1 is 2, which is smaller than in length of p. Sorry, this should be length of f. 3. Okay. So I can move actually. So frequency map s row minus equal 1. So a should be decrement 0. And for them, I low point. Then I high point. And the frequency map with A. Now actually let's go back to 1. And in line 73, key frequency map and frequency map are the same again. So append row, which now is 1. Good. I come back to line 67 because high plus 1 is I go to line 60. I decrement B and move height and increment. So now they're not the same in line 73. So I go back to line 7, but now high plus 1 is so the end of the while loop. So I go to line 6 and return 0, 1. Okay, expected. Fast. So far I covered all the lines in the main method and confident in my code. I will submit. Change my mind. I mean, good, accepted. Okay. So let me quickly wrap up. So today I solved the question: find all anagrams in a. So in this question, I was given two string s and p, and I should return the list of index. I mean, which the starting index of p's anagram in S. Yeah. So in this question, I use the sliding window, which has a fixed length of p. Yeah. So I move sliding window, and every time I sliding window updates the factor counter of the current window, and then compare it with given p frequency up. They're the same. It's to be included. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.